maybe a couple of hours to learn chicken. And chicken is really the only scheme that I've written in. So I wrote this in chicken using the PDF egg, and took me a few hours to learn what to do. Took me another couple of hours to work out how to make these snowflakes recursively draw themselves, and I've used it every year since, and it's been a massive time saver. So I recommend this. So that's just a bit about me. This is Nodium, which you all came to see. So you probably didn't want to see the console output, but basically we run our program, and then it comes up, and there's a REPL there for inspecting the web server while it's running. So you can do some debugging and look in the database and this kind of thing. Has anyone been to the Nodium website? Has anyone even heard of it before or looked up before? Okay, so this is us. What we're doing is we're building communication and collaboration tools for students. So let's say you're studying chemistry or something, and you're at university somewhere. Often you go and visit your lecturers, you send them emails, maybe you meet up in coffee shop with your friends and draw things on bits of paper and push them around the table and this kind of thing. And lots of universities have big learning management systems and virtual learning environments which try and bring this part of education online in the same way as you can go online and socialize with your friends on Facebook at any time. They're trying to bring this aspect of education online as well. And we find that one of the big missing pieces of this is actually that experience you have in your coffee shop with your friends, where you're drawing these diagrams. So you can't do this on the software provided in university, and you can't do this on Facebook or whatever. We were finding a lot of chemistry students, for example, were writing in Facebook groups with their peers, and they were going to bits of paper to draw their questions, and then taking pictures with their phone and uploading it to the Facebook group and trying to attach it somehow and then reference it from the comments, and this kind of workflow wasn't really working for them. So we're trying to bring kind of much stronger collaboration tools onto the web where you can just point and click at this kind of stuff. So that's what we're building, and it's all entirely in Scheme, apart from a couple of minor things which I shall highlight as we go along. So this is our site, and we have institutions in the UK signed up. So at the moment, it's just in the UK. We're going to move out into other countries, hopefully quite soon. So you can press this button and to log in via your institution, and you get this screen, which is part of a identity federation. And you can type in your university here, and then it redirects you to your university, where if you went to Cambridge University, you'd see this page on their website. You log in with your university credentials, and then you come back to Nodium as a member of that institution. And so that's one of the little bits of integration between Scheme and other pieces of software and other web interfaces that I'll talk about that we did. And this is the Nodium main screen that you see. So we've got the usual features you expect. So you can search. You've got user profile stuff. You can change your name and this kind of thing. We have this navigation bar, which again more details presently. And then we have these groups called hubs, which are basically where the discussions happen. They're like chat rooms or whatever you might be, or groups or whatever you might be familiar with. And users can come along, create their hubs, invite their friends, and use the tools in there. And then this sidebar, it pops out when you put your mouse on there, and you can see these are the hubs that you've subscribed to. So this is a picture of an actual hub. You've got the details and the name and the description and this kind of thing, and the list of members as you would expect. And then these topic blocks, which are where the posts happen, and you can compose your post, and then you can include things like LaTeX notation, which gets rendered into the maths that you might want to talk about, and this is the second post, which is in reply to it. So pretty usual stuff, but with maybe a couple of extra features that make it much more applicable to discussing things that aren't just text-based. So you can also include maybe a chemical diagram. I don't even know if that's a real thing. Apparently it's a cool phosphate. I'm not a chemist, I have no idea, I'm afraid, but you can put him in, and this is the editor that you use to put him in. So he's, standard HTML5 WYSIWYG editor with bold and underline and all the things you'd expect. And then we have the chemistry editor in there as well, where you can click on these benzene rings and join up these carbon molecules and these hydrogen molecules. And the editor is actually a piece of software from a company called ChemDoodle, which chemists, they tend to use this already during their studies, and it knows about chemistry. So when you put a benzene ring in there, it knows how to draw it, and then if you put a hydrogen atom on it, it knows which links to take off and which links to add, so that you always end up with a chemical that's not entirely crazy, right? So that's quite powerful for them. And then we have this ability to import random documents. So we can link to your Dropbox, and then once you've downloaded the file into Nodium, they show up in this list, and you can view the file in the browser. And then you can say, well, maybe I'm a music student, maybe this stave I'm having a bit of trouble with. You can select it with your mouse, and you press this button, and then it chops it out of the PDF, and then you can paste it into your post as well. So I didn't have an example of that particular stave, but here they've put in a snippet from a document about log structured merge trees, and then they can discuss it in there, ask questions, this kind of thing. Here's some people have put in some slides from a presentation they're working on. And so that's a quick overview of the product. That's kind of the output of what we do. And now what I'm going to talk about is actually how we do some of this stuff in Chicken Scheme, and the kind of the challenges we had. If anything's not clear, just ask questions at any time. If I'm talking rubbish, then clarify stuff, because there's no point in me standing here and you guys not enjoying yourselves, right? So Chicken Scheme is a R5 RS scheme, so it's reasonably modern. There's some other schemes which are on the 6th version of the standard, and the 7th version of the standard is being standardized currently, and that should be what most of the 6 and 5 versions are going to converge towards, we hope. But currently it's a version 5, so you get basically a very simple Lisp with lambdas and car and CUDA and some first-class continuations, first-class tail calls, and then the rest is built as packages. So I think Chicken Scheme's been going since around 2000, 2001. So it's quite mature. It compiles down to C. So some of the advantages of that are that we have a very strong foreign function interface. And you say this to people, and they say, well, so what? Foreign functions, what's that all about? What it means is that because it compiles down into C, we can use any C libraries that you have on your system, right? So most libraries are written in C. So OpenSSL, we can bind to this API, and then we can use that in our web server. And we have a web server written entirely in Chicken. We bind the OpenSSL egg into there, and then it can do HTTPS without any more kind of development effort. So there's loads of stuff that you can pull in. So Cairo for graphics, SDL for writing games. All these things you can pull in. You can make a binding, and then you can write your application in Chicken. And this makes it really kind of really powerful, general purpose, really quick to actually deploy for real programs. And also, one of the best aspects of Chicken is the community. When I was getting started, I just potted along to IRC, didn't really know what I was doing. They helped me out, they fix bugs, they get everything sorted, so I'd definitely recommend. They're very friendly, some of them are here. Does anyone use Chicken? So some people. Has anyone used other schemes or other Lisps? Excellent, so we've got a bit of a mix of people. What does it say here? I see. So what, you know why we chose Chicken as our scheme, but why would you choose to write this kind of thing in Scheme, right? You've got things like Ruby on Rails, Django, C#, all these kind of things which have strong web frameworks and web tooling, right? So I guess the philosophy is kind of very different. There's much more of a toolkit rather than a framework approach, and personally, I find the frameworks very difficult to work with. I prefer a kind of a toolkit of libraries that I can build up from rather than a framework that I kind of build down from and within the constraints of. So we did some prototypes in Nodium when we were looking for funding and when we were trying out stuff with users. We had one written in C# and we had one written in Python on Django, and they worked really well for the prototypes. We got lots of stuff written really fast. We got lots of stuff in front of users really quickly. And then we found that when we actually came to turn it into a product that we could roll out to many universities and many users, that we kind of hit abstraction limitations, so we say. So it was really hard to take the bits that we'd used in the prototype and then refactor them into more general tools that could be used on, like maybe snipping PDFs as well as snipping images and these kind of things. And we found with Scheme, if you build it up from lower level things, then you get a bit more flexibility with how you compose the stuff. And Scheme itself is a very composable language, and that's helped us a lot in kind of a lot of actually stuff I'll talk about towards the end when we're finding software engineers and getting them up to speed. Because two of the main things people say is, Scheme doesn't have any web frameworks. Are you going to write your own? Are you crazy? The answer is yes, we are going to write our own, and no, we're not crazy. Well, maybe we're crazy, but that's irrelevant. And how are you going to find people? Like, no one writes in Scheme, right? So you're not going to find any software engineers. And these things in practice turn out to be not as much of a problem as you might think. There's far bigger problems that you have when you're trying to build a product and get it in front of users. So, yeah, the question of, well, there's no web frameworks in Scheme. It's kind of true, but it's also kind of irrelevant. Chicken has a very strong web server, so it's a web server built in Scheme in Chicken called Spiffy. You can run this up, and it'll immediately start serving files off the current directory, and you can add in hooks and handlers to start doing more dynamic pages straight away. So that's pretty good. It's got a very strong set of kind of web tooling, if you will. It's kind of got very strong URI parsers, so you can take in URIs, break them up, recompose them. It does all the escaping for you, handles all the security, a lot of the security issues. I think all the security issues. We actually did have an injection bug, and it was entirely our own fault. We fixed it. And it's got strong HTML, so it's got this core of strong HTML tools and HTTP tools around which are built actually the web server and a web HTTP client. So when we're querying other web services, we can use the inbuilt client for this. And it's got a really strong SXML toolchain. So SXML is just a Lisp representation of XML hierarchies. So you can express HTML pages and these kinds of things in S expressions directly. So it actually turns out that even though there's no explicit stuff there's a lot of tools that are more general that are quite applicable, and there's a lot of implicit things in the structure of the language, like having a hierarchical structure that fits well with HTML, rather than in other languages where you're basically packing strings together in order to build up responses, or you're kind of building up chains of procedures in kind of promise APIs and this kind of thing. So yeah, it turns out that it's actually quite a good language to do these kinds of things in. Some of the other useful parts of the language are things like the syntactic abstraction. So macros, everyone says, these are great things. It turns out in Scheme that in Lisp, I think macros are quite strong. In schemey languages, I think people tend to prefer to use procedure where possible because it's first class, so you can pass it into higher order functions, and it's generally a bit more composable. So macros tend to take a backseat. They tend to be kind of this big headline thing. Everyone says, come to Lisp, come to Scheme, come to Lisp because we have macros, and you get there and no one uses them. And then occasionally you see one, and those times when you see one, that's really important because there's a lot of powerful things going under there. And I'll show you some stuff later where we've used this macro, and it's really hard to do a demo because it's just like, yeah, this is 2 lines. It's really cool, isn't it? And you go, yeah, so. But those tools have to be built somehow, and sometimes you have to resort to these things. But another part of the syntactic abstraction story is actually quasi-quoting and quoting of data structures. So the kind of what they call homoiconic, where data is a certain structure and code is a certain structure, and these structures are the same. So if you've got a tree of S expressions, you can say it's code or you can say it's data. And one of the ways you flip between these modes is with the quoting operators. And it means instead of calling all these procedures which build up your strings, or calling all these procedures which build up like lots of closures and kind of fairly opaque structures once they're built, you can just say, right, I want some data now, and here's my XML tree. And then during the process where you're typing your tree in, you can say, actually, I want to unquote now, and I want to put in a little bit of program which maybe builds up a list of these hubs that I'm a member of, or something like this. So that's a really strong abstraction mechanism. So a lot of our source code just looks like trees of pages that you're going to view on the site, and there's not really much else around it, which kind of keeps the places where you can put bugs fairly minimal. And I could talk about other great Lisp things, but you probably think I was crazy. Those are the main ones which make it a kind of a very strong language for doing especially web stuff where you've got a lot of hierarchy. So chicken is what we implemented in. What bits do we use? So there's units which are part of core, so that you've got the core language, and then around there you've got a load of inbuilt units that do things like TCP and ports and lists and this kind of thing. We use around 8 of those. And then there's this another set of packaging which is called eggs, and they're all the kind of modules that people build completely independently on top of the language. So things like the web server and the XML tooling and the HTTP clients and this kind of thing. We use about 20 of those, or 26 of those when I counted a couple of days ago. And about 4 of those we wrote ourselves and contributed back. And because this is an open source conference, I'll talk mainly about those. And we have 5 more internally, which either they're private because we haven't got around to releasing them yet, or they're private because they're just do something for our particular data or something like this. Reasons for keeping an egg private and releasing it are really way more complex than I thought they would be. I thought that you just kind of go along and wave your arms and say, how great, we're doing open source, aren't we cool? You can all come to our community. And it turns out that this isn't the case at all. A lot of the times you want to release the code because you had some need for it, but it's not really a core part of your work, and so you think maybe other people are going to be interested in this, and yeah, it's going to raise your profile and give you some PR. But other times you want to release the code, but you can't because of the way development cycles work. So maybe you've put a lot of effort into it, and it turns out that there's some bugs, and you need to fix them in a certain way. And if it's a private bit of code, you can fix them and get your product out and take a few liberties. And if you've already released this piece of code and you go back, sometimes you have to fix the bugs in more clever ways and take a lot longer about it. And if this is a piece of code that actually isn't a core feature of your product, but is a core part of your product, then it's really hard from a business perspective when there's just a few people and you're spending VC money. It's really hard to justify a lot of development effort on this piece of work, even though as programmers we know it's sensible, right? But I guess the effort you put in goes up exponentially when something's public because of expectations around the code quality. So it keeps you honest, but it limits your options in some respects, and so you've got to be really careful about when you release stuff and when you don't release stuff. And so there's a few in these five eggs that we're going to try and get out one day soon, I hope. And then we have these kind of private modules as well, which are just modules are like the shared library system. Usually we just have one that does like our particular brand of how we do HTTP sessions and this kind of HTML sessions and this kind of thing. So these are some of the eggs we use. Spiffy is the web server we use, which is probably one of the most important parts because we're a web application. And SQL Delight is an egg which binds to the C API of SQLite, which is a little database engine that we use internally for some things. SSACs and SXML transforms, these are the SXML tooling and XML tooling for Lispy languages. And the SACs project is actually I think it's independent of Lisp, and people port it into their implementation.
Yeah, well, it's scheme specific, but it's standard code, so you can import it.
Yeah, so Chicken have an import of this, and we use it for generating our pages, which I'll go into presently. And Spiffy, again, it's this web server written in Scheme. It talks on TCP ports. It talks HTTP to clients, and then on the back end, you've got stuff, right? You can fetch files off disk, or you can fetch results from procedures and return them. But for some of our stuff, we have to talk to external CGI programs. So a lot of the way we integrate with the login system is via external CGIs. And so we wrote the fast CGI implementation for Spiffy to do this. Then I mentioned before the OpenSSL egg. This just allows us to import, again, a big blob of C code into Scheme and into our web server and get HTTPS working. And then this thing called SSQL, which is, has anyone heard of this? This is like SXML. It's a Scheme representation of another language. It's a Scheme and S expression representation of SQL statements, and it allows you to, Lisp people will stand up and they'll say, "These great, we've got these S expressions." There must be some advantages other than you get to type more parens, right? And one of the advantages is that you can, because they have more hierarchy, that they kind of try to reflect the hierarchy of the SQL query, so you can compose them. You can say, I've got this SQL query. Maybe it's a select from a table and then a join onto two tables, and then maybe a where clause. And you can say, well, actually, I want to scope this table, this actors table that I'm joining to. I only want to know about actors from the last 3 years. So you've got this where clause that says actors greater than or equal to 2010 or something. And because SSQL knows about the structure of this SQL statement, when you compose it, it can grovel down the joins and find every place where you use this table, even if you aliased it with the as clause or something, and it can make sure the where clause gets applied consistently on this table. So that's quite a strong thing to be able to do. Peter here has an excellent blog series on these different essentially domain-specific languages like SXML and SSQL, and there's another one which we don't use called SCSS, which is an S expression representation of CSS, and he does a really good treatment on the trade-offs and why they're good and why they're bad. And it turns out that SXML is probably amongst the strongest. It reflects really well the underlying XML because it's essentially the same structure, and it has similar kind of nomenclature and stuff. The SSQL one kind of works. It turns out that a lot of the serialization formats of SQL statements vary between engines, and there's a lot of problems with actually getting it to work in a really elegant way. So the kind of the top of the API looks like it works really well, and the bottom of the API it's really, really hard to implement. But it's kind of on the tipping point, and it generally comes out to be a win. And then the SCSS we looked at, and we're already using Ruby's Sass implementation for all our CSS compilation. So that's one of the areas where we don't use Chicken. We actually, as part of our build process, use Compass to build our CSS assets. And we looked at the Scheme language, and we couldn't see any clear benefit of changing from one to the other. Maybe if we were implementing from scratch, then the trade-offs would be different. I'm not sure, but again, it's probably slightly tipped over the balance of actually providing enough extra power for the extra kind of complexity you have of not using the native format of the thing that's in your browser. So you have to choose quite carefully all these things. And maybe we made the right choice, maybe we made the wrong choice. SSQL, it works, but we'll see. I don't know. So yeah, the other technologies we use, like I said, we use Compass in our build system, which isn't chicken, and we use this big piece of software called Shibboleth, which is anyone familiar with SAML? So SAML is Security Assertion Markup Language, and it's an XML application which things called identity providers and service providers use to talk to each other and exchange security stuff. And it sounds really complicated, but basically it just allows us to implement the functionality where people log in via their university. So we talk this SAML protocol we need to talk this SAML protocol to all the universities, and they need to talk to us. And so Shibboleth is this piece of, it's C++ on our side. We run this C++ piece of software, and then it talks to our web server via fastCGI. And so we need to expose these SAML assertions. They come in via SOAP queries on our HTTP endpoint. So somehow we need to expose this endpoint to the world via our web server. So we have a fastCGI implementation which we put on a URL, and then it just shuffles the data to and from Shibboleth, and then eventually it inserts some headers into the page where we can see which user logged in and how they logged in. So that's kind of a big external integration that we've done using fastCGI rather than the foreign function interface or anything like this. It wasn't actually very difficult to get working. The fastCGI implementation, I just looked at the fastCGI spec and wrote that quickly in a few days, and fixed a couple of buffer overflow bugs in Shibboleth where it turns out Shibboleth have an Apache module and they have some fastCGIs. I don't think anyone else uses the fastCGIs because they had some buffer overflows which made them not work if you try and log in twice and stuff. So that was, again, one of these. It's one of these interesting trade-off points of using prepackaged software, right? Because on the one hand, we turn around and we said, right, we're going to write our application in Scheme, and we're going to not use any existing languages with existing frameworks, and we feel comfortable with that. And everyone looks at you and says, but there's implementations out there, you should use them, they're high quality, they work, loads of people have used them. And maybe you choose not to do that. And then you take a big professional piece of software like Shibboleth, which is maintained by a ton of leading security experts and C++ experts around the world, and you think, well, it's an external piece of software. SAML's really, really hard, and I'm not interested in implementing SAML. I just want to get the benefits of having these users be able to log in. So I'll take this piece of software off the shelf. And it turns out that the most difficult part of software engineering is integration between two things. If you know one thing and don't know the other, that's pretty hard. If you don't know either thing, that's seriously hard. And you can actually make a lot more mistakes gluing these things together than you can just sitting down and writing the little thing that you need. And the really interesting part happens when you start off with, I just need this simple thing, and then it kind of grows, and suddenly you're well out of your depth, and I don't know how you have that experience. Sometimes I feel like I can make that choice, and sometimes I get it right, and sometimes I get it wrong, and I think that's basically what a lot of these conferences are about, where you come along and people tell you these rules they found out. And unfortunately, even though I've got a bit of experience, I have nothing more to add other than choose carefully what you build and choose carefully what you integrate with, especially if you're buying software, because it's an open source conference, so you expect me to say that open source is great and blah, blah, blah. But if you don't actually understand SAML or whatever, it turns out to be pretty difficult, even if you've got the source. So you do need to be pretty careful about when you're buying software and when you're using free software and when you're building your own. So, enough waffle from me. We're building these pages and we're sending them out to the client. And I could show you one of those hubs or something where we've got the details widget, and it turns out that the details widget's pretty simple because it says the name of the hub and the description, and the HTML for it's about this long because we've got curvy borders and all this kind of rubbish. So I'm actually going to use different example, which is a example I built. So waffle is our widgeting template, or our widgeting system that we've built as an egg in Chicken, and it didn't stand for anything, but I think we decided that it might stand for widgets and forms for list enthusiasts, something, which is slightly contrived, but it's also cool. And one of the things that I built in order to work out whether it was working and whether I was on the right track was this implementation of Helvetic cards. Helvetic cards is a set of CSS playing cards made by some chap whose name I forget. He'll be in a comment in a minute, so I'll credit him properly presently. But they're a set of HTML and a set of CSS, and you put them together, and you can make pages of playing cards like this for your game or whatever it is you want to make. And what I wanted to do was take this HTML and make a widget where I could say, I want to make the 2 of clubs. Give me a playing card that's the 2 of clubs. And so when I'm writing my web app, I can just deal with the 2 of clubs rather than this big blob of XML. So the things that the cards have on them, they have the number, and in the 2 corners, and they have this little glyph of the suit. And then they have, in the middle, they have the suit again, and the number of times it's on there depends on what the rank of the card is. So the 2 has 2 of them, and the 4 has 4 of them, right? And if you look carefully, they're in slightly different places. So how do you make this thing go? The 2 has this one in the middle, and the 4 has nothing in the middle. So there's like 3 slots, 3 columns, and then the 5 has these 3 space like this, and the 8 has these 3 space like this with this one in the middle. But the 10 has a slightly different offset for the ones in this column. So it's not entirely trivial to just put these things, but hopefully we defer some of that to the CSS. And so this is basically what we want to write in our source code, right? We want a bit of data with this quasi-quote thing. We want a Helvetic card, and so this is SXML. In SXML, you put the name of the element, your name of your XML element, and then if you have an @ this isn't a valid XML literal, so we overload it and we say this is the attribute list. So the set of attributes that appear on your XML. So if you have an image, then you have src for the source equals, and that's the attribute, and those appear in this list. And so we want one of these Helvetic cards, and we want the suit to be clubs, and we want the rank to be a 2. And I've used a symbol here for 2. I could have put a number, but for the purpose of the example, so it makes it clearer how some of the other stuff falls out, I'll use a symbol. Zach. I still can't pronounce his name. This guy, he actually wrote the underlying HTML and CSS for this, and I just wrapped it in this widget so that you can get any card you want from the deck. First, in our widget definition, we specify what are the attributes. So we want to say what the suit is and the default, and what the rank is and the default, and then maybe this name thing, which I'll come back to in a minute when I talk about the forms aspect. So those are the things that we're going to allow to appear in the attribute list. Certain more complex widgets can also have kind of contents. So inside there you can put more XML. So if it's a post, like on the Nodium demo side, you have a post. The post has an author, which maybe is an attribute, and then the post has some content, which maybe is its own XML tree of paragraphs and divs and these kinds of things. And so the content is handled separately, like it is in XML. And then you have the markup section, which is essentially, because we're Lisp, right? It's essentially a little program, but it might not be. Who knows? When I evaluate these widgets, I read them in from files, so that you can put a file in a directory and say, this is my widget called Helvetic card, and here's my implementation of it in this file. When I read these files in, I constrain the environment. So I just say, give me the plain R5 RS environment. So the things you can put in here are reasonably powerful. You can bind symbols, you can call Lambda to make procedures if you want, but you can't just get arbitrary parts of the API. So it kind of enforces a little bit of abstraction between your widget and your page layout. You don't want to. Where to draw the line is really hard. A lot of web frameworks have templating engines which don't draw the line. And actually drawing the line is hard, but essentially you want this model where you've got these widgets and you compose your page out of widgets. But when you actually look at the details, maybe these, if you take it to too far, to too many extremes, maybe these widgets become just entire layout engines in their own right. And where to draw that line, I guess, is a matter of taste. So we give you a fairly empty environment, so you can't take too many liberties. And then when you want to take a liberty, you think about it, and if you want a symbol, you decide you really want a symbol, you can put it in the environment and make it available to the widgets to use. So we start off our markup by defining this thing called ranks, where we just have this A list. So an A list in Lisp is an association list, has a set of keys in the first position, and then a set of values in the rest of the list. And when you look up the key in the list, you get the rest of it. So if I looked up 2, I'd get this list containing this string with a 2 in it, and I'd get this list containing these symbols. Everyone's familiar with the symbol type, right? So a symbol is just this, it looks like this little bit of string you can put in your source code, but it compiles down to just like this little reference thing. And so this top center here compares equal to this top center here, and it does it in an efficient way and allows you to kind of have symbolism in what you call that name. Am I being clear? Yeah, cool. So when you look up rank 2 as passing from the attribute, you get this number, and then you get the list of places where you're going to put the glyphs. And we define it for all the cards. And so for the jack, this is part of the why I chose symbols here, is because of typeness. For the jack, we want this J. So we always return this thing as a string. And then we just want kind of the J glyph in the middle. So here it is, if you couldn't see it before. We just have this A list of ranks, which is each rank in turn and what the card looks like. And then we have the suits. We have the similar A list for the suits. So the clubs is this HTML entity, which looks like a little clubby thing. And this ampersand again is SXML for HTML character entities. When you serialize them, they turn into the correct HTML thing. And then we have this thing which looks up the glyphs. This is a particularly filthy implementation of A-list ref because, like I said, you only get the bare environment, and so A-list ref's in the bare environment, isn't it? No, in Chicken it's in this extra unit. You have to import it. So I didn't have it by default, and it just pulls out the rank. It pulls out this list using this, and then if it didn't exist, so if this returns false, we execute this part of the OR, which is this underscore and then middle center. So if you ask for a rank like 13 or 11T or something, it'll just give you this underscore in the middle of the card. And then the actual glyph itself, we look in the suits and get this guy out in a similar way. And if you put in like the 11T of Rolos, then you'll get a question mark with an underscore, right? And then the actual number we want to put on the card. So that's the number as you know it, like 10. And again, if you put in the wrong number, you'll get an exclamation mark in the number position. So you'll get a card with like an exclamation mark. Let me wind back a bit. You'll get an exclamation mark here, an underscore here, and then an underscore there in the middle. So that's the logic of the widget. And then we have the SXML template. And the way we do the actual templating is just by writing the data for the XML tree using this quasi-quote operator, so that when we want to splice in, say, the thing we looked up for the suit, we just unquote and we put it in, and then we put the rank in. And then this is the, here's our card. This bit comes from here. This is the div which goes in the top corner, which has the number and the glyph in. Then this bit here is the bottom corner with the number and the glyph, and then this bit in the middle just maps over all the glyphs that we got from the list, and then puts them in the right position. So for 9, where's 9? 9, it's like top left, top right, middle left. Sorry, top left, top right, middle, top left, yeah? So you get top right, top left, and then middle, top left. And it maps over all of them, putting in the right bit of XML for that glyph. And so you can write reasonably, this appears to be a fairly simple thing, right? But it turns out to be a much more complex example than just the details box on the Nodium page, because it's got all these kind of different properties about where you put things, and there's an elegant way of working out how to actually construct this XML up. And then you can just say, I want the tour clubs, and it'll build that XML and pop it into your document for you. So there you go, there's one of those cards, there's the tour clubs. What about the rest of those guys? We want loads of them, right? So here, this is the entire handler for that whole page. So when you go to this /dex thing, here it is. That's what runs. And so we have this widget that describes the game page as a whole. So it gives you, if you've got an app that's got a certain look and feel with a toolbar and this kind of thing, you can define that in the page. And then we have a table on which we want to put the cards. So if you were going to extend the game, you can make this maybe a green table with like little corners and stuff. And then this is where you have to kind of make your decision about the factorization of your widgets. Because here we unquote, and then we run this procedure called render hand, and then we pass to that procedure this kind of the output of the shuffle deck, and we pass a deck in. And these aren't widgets, but they're probably procedures that do return widgets. Is everyone following? Am I making sense? So here's the render hand. It just maps over the whole hand that you pass in, which is this shuffled deck, and builds a playing card for each of them. And then you get your page of playing cards. And this one just does a random, every time you refresh the page you get a random deck. It shuffles the deck, gives you, and then puts all 52 cards out on the table. So that's the widgets part. And then we have this forms part. So say you've got this address widget, right? You said my widget is 2 text boxes, one where I put the guy's name and one where I put some address. I want to ship him this deck of cards I made or whatever. And then you want to reuse this widget down here for the invoice address as well. What you want to do is your widget needs to output this input, right, with this name, and then this input here with this name, and it needs to be distinct from this one and this one, right? But you need to, you want to use the same actual widget for it. You don't want to have like an address widget and a invoice widget. So actually in Waffle itself we have support for nesting these widgets inside each other and dealing with the forms. So if you're building a complex web app where you've got an invoice and then there's a couple of addresses and then there's a load of invoice lines with each one with a invoice line widget and all these kind of contrived examples you see in database magazines, you can just compose the widgets and then the names will fall down. So here's the markup for that page. We put the heading in for the shipping details, then we put this HTML form in, then we put the invoice details, and we put the HTML form in again. And in the attributes we have this special thing called name. We say the name of this widget is ship to, and the name of this widget is invoice to. Then the widget itself has the label, which prints the text, and then it has the actual input box. And the input box, the name is called to, and the name of this one is called address. So the widget itself it just defines the names it's kind of like scope. These names are what the widget calls them. And then when you put the widget in the page, at the time the page renders, it'll find, at the time the page renders this, it'll render this guy, then it'll render this guy, and this guy will expand to 2 input boxes, and it'll know that the widget it's rendering is called HTML4, is called ship2, and so it'll look in the output of that part of it'll stop the rendering stage there, it'll go through the generated markup, and it'll find things which it knows to be HTML forms. They're defined in the spec as things like button and label and input and this kind of thing, and it'll find things which it knows to be waffle widgets, and it'll propagate the name down to them. So if you can nest these things arbitrarily deep, and you can, and the names will just short sort themselves out, and then when you get the form post on the other side, you can pick them apart again and work out which parts corresponded to which buttons and this kind of thing. So that's how we do the forms aspect. The CGI handler I spoke about already, we just use it to integrate to the Shibboleth login system. And they send us XML and SOAP and stuff, and we pass that through to the C, and then it passes us back who the user is. Web API, so I showed you the bit where you can add your Dropbox, and then you can import the file and take the snippet out of it. So it turns out that you need quite a lot of infrastructure for this. There's this thing called oauth, which you're probably all familiar with, but basically there's a service provider like Dropbox, and there's a user, and then there's us. And the user wants to upload their files to Dropbox and then tell Nodium to download them from Dropbox, right? So the user wants to tell us, to tell Dropbox, to ask them whether they're allowed access to the Dropbox, and then they tell us they are. And so next time when they come along and tell us that they want to download a file from Dropbox, we can just get it directly. But that's essentially what oauth is, right? So again, one of the downsides of using Chicken is that there's none of these excellent oauth implementations that everyone else has done for years. So we had to write one, and it took me a couple of days to read the spec, and it took me a couple of days to do the design, and then it took me about a day to actually implement the thing, because it turns out it's not actually that complex. It took us a little bit longer to then do oauth 2. So probably we've spent 2 weeks in total, maybe a little bit more than 2 weeks, to write an oauth implementation for oauth 1, 1A, RFC of 1 and 2, and some variants of 2, which everyone uses, because it turns out that standards are great. But what the API gives you is, it allows you to define a service provider. So you say make oauth service provider, then you say which protocol they use, and then you say the 3 HTTP endpoints they use for that crazy little shenanigans with the circle and the arrows. And so you just declare all these, and if you've got an egg that's got a binding to Dropbox, then they'll probably provide this bit for you. And then you define your app, which is where you take the service provider definition and you poke in your what's called the client credential, which is, as Nodium, that's our secret for talking to Dropbox with the client, not the user. And so then you get a Dropbox app out, and then somehow you do the dance. There's APIs provided to do this dance, but they're a bit boring, so I won't go into detail about them. And you end up with a user credential. And then you can say, with something is kind of an idiom in schemy languages where you say, where you have some kind of special environment that the enclosed procedure executes in. And with oauth, you give it your Dropbox app with your service definition and your client credential in it, and you give it the user credential, and then you give it a procedure to execute. And this procedure, call with input request, usually comes from the Chicken HTTP client, and it'll fetch this URL for you and give the body back to you as a string. When you're inside this oauth argument, it overrides this call with input request, and it makes it, first it signs the request in the way specified in the Dropbox app, and then it does the call through to the HTTP client, which gets the result. So you can just wrap your whole program in with oauth, the credential, and then every time you make a request to a web API, it will sign the request for you, and you don't have to worry about this anymore. And then this call with input request takes a URL, and it takes a writer. So if you're doing a post and you want to send some data, you can write it there. And then it takes a reader, and here we just read the string, read the whole string, and there you go. It gives you this stuff, this JSON back. And this is whatever structure that Dropbox say in their documentation you get for when you call the account info API. So that's the oauth part. And then we have this thing called REST bind, which is for binding to not just REST APIs really, but any kind of HTTP API. As you saw here, you've got to, if you want to make a call to this endpoint, you've got to call it with the HTTP client and pass in these things, and then it returns you something that you don't really know what to do with, right? This isn't useful. This is a string that you've got to pick apart somehow and read it with a JSON reader and maybe turn it into another more internal data structure like an S expression or something, or a record or something like this. So we have this thing called define method, and it works a little bit like any kind of procedure definition in the scheme. You tell it the name of the procedure, and you tell it the argument list. The keyword arguments get put in the query string, and so if you look in the Dropbox reference, they tell you that if there's this one in the query parameter, you can put locale that says what language you want the reply in. So we bind that, then we tell it the URL, then we pass in a writer. So if we're implementing the file upload API, we pass in something that actually sends the contents of the file there, and then we pass in a reader which reads the response, which, as you saw, was it was JSON. So we have this read JSON procedure defined somewhere which takes that and then turns it into an S expression we can pick apart, and then that's all the bits I've just shown you. And then this is the reply we got before, and this is the request we did before, and now we've bound this API. We can just say with Dropbox call account info, and then that will, if you call this with the pretty printer, it will return you an A-list, and you can pick this apart with your usual A-list ref or whatever tools you want to pick it apart with, put it in databases, all this kind of thing. And you just work through the Dropbox implementation, and you work through the Dropbox API, you implement a binding for all of their procedures that they define, and then you've got a low-level binding. And this takes about, I think this was 500 lines, of which 450 were comments, which part was like the URLs to the Dropbox documentation and this kind of thing. And the rest was just this procedure name, these are the arguments, here's the endpoint, bind me an API. And so at Nodium we wrote this thing for binding to these REST APIs, and it works nicely with the oauth binding that we wrote. You can put them inside there, and it'll sign all the requests for you. So that's quite a lot of the technical stuff. Can I have 5 more minutes? Yeah? That's a lot of the kind of the technical stuff that we did at Nodium to make our web app, make it work, make our lives easy, make it easy to build. And there's still the questions of what about all this soft stuff? You know, where do you find these developers? How do you get them to come and work for you? And when they come and work for you, they've probably not written Scheme before, right? And it turns out that training isn't too hard. I have this theory, I'm still working on it, I have this theory that Lisp actually, in scheme-like languages, actually get harder to learn the more computer science you've done. But a few people I've employed they've been really clever, they've been doing science degrees or whatever, but they've not done much programming before. And I take them in the meeting room on their first day and I say, I've got one here. Here's an S expression. The first position is the operator, so plus or minus or whatever you want to do. The next positions are the arguments you want to do it on. And then when it runs, imagine that this thing, these parens, are replaced by whatever it evaluates to. And you wind them up, you send them off, and they can get pretty far with this. Especially if you've got a code base already. You tell them that much, they go away, they can start reading code, and they come back with intelligent questions. They don't come back with, oh, how do I check it out from Git? And stuff like this. They actually come back with, well, you see this if statement, how come the branches don't evaluate themselves? And this kind of stuff. Then you have to explain macros. So that works pretty well. Also, because of the structure of the language, it's just expressions, and so you can put anything anywhere. Once you've got something that does something, you can close it in parentheses. It's probably enclosed already, and you put it somewhere, and it does the same thing as if you put it somewhere else. So once you've got a fairly big code base, you can get people started pretty quickly, and they can generally read it, given the rules you've given them, and they can read the code, and then they can say, well, I want this bit, and I'll put it over here, and I understand the structure enough that I can edit it. And so copy and paste programming actually works. In other languages, you have, like, it kind of trips you up. You have all this extra syntax. You need to worry about whether you put the semicolon or the closing brace and this kind of thing. And you spend, I mean, it's trivial stuff, right? But you actually, as a programmer new to a language, you spend a lot of time worrying about that. And I think in Lisp, if you're writing from scratch, certainly when I wrote my first program, I spent a lot of time worrying that all my parens were closed. But if you've actually got a working code base and you throw someone into it, they can actually get stuff to work, and they can change stuff, and they don't have very many compile errors, it turns out. And this was actually quite surprising to me. Other pains we have deployment pains. There's some bugs in chicken deploy where it doesn't traverse the dependency tree, so we actually just install chicken on our live site and build it from source there, and that kind of works for now, but we're not going to grow to millions and millions of machines like that, so we need to go back and do all that deployment stuff. But again, as it's actually a compiler, and it compiles down to a binary, which is the web server, because we have our own web server, it's all self-contained. So at some point we just build it, and then we put a binary somewhere, and we can use quite a lot of simple things like OS package managers to install it, rather than having to worry about having a server that we inject some stuff into and all this kind of craziness that you get with interpreted languages. So we have pain there, but hopefully it's pain because of bugs, not pain because of fundamental issues. What else do I have? Yeah, the other issue we had with new people, my co-founder had never written Lisp before, and I'd only ever written this Christmas cards app. And I showed him this waffle thing that I was planning, and he came to me and he said, yeah, this isn't going to work. Maybe I can deal with it, but designers are going to be very sick if you show them this and make them learn this foreign alien syntax. So we started working on this widget explorer, where it's a web page that renders the widget, and then it gives you the SXML and it gives you the XML, and you can edit. The idea was you can edit the XML and it will back propagate it and then re-render the widget, so you can kind of have this interactive widget editor. And we got about halfway through this, and we ran into an issue where in the SXML you can have these quoting and unquoting, and then when you render it, you put in a variable name for that. For all those substitutions, you put all the substitutions in. And it turns out that you don't want to render it, you want to serialize it in some other way. But it turns out if you serialize it in some other way, you have all these unquoting things which you can't represent in XML. You can't serialize it back again. And I'm sure there's a way, but by this time I was scratching my head one morning, and my co-founder said to me, oh, it doesn't matter, we don't need it anymore, I'm okay with these parents now. So I think it takes maybe a week or two to kind of get over that first hump, but if you persevere, then it's one of these things that people fly as a flag, like macros, and it turns out to not really be that relevant. So yeah, that's me, that's Nodium. If there's any questions?
You mentioned that these programmers are maybe not so worried about, for instance, where they're placed, because they're pasting code that exists or not.
Yeah.
But if they're editing it, are they using something like FrOSCon to keep the structure?
So I use Vim, and it doesn't have PowerEdit. A lot of other people who work for us using Sublime Text, and that does have PowerEdit, and it has lots of juicy bugs. It somehow manages to generate unbalanced parentheses sometimes. But yeah, they use some PowerEdit, but probably not the Emacs one you're used to.
So it's not really an issue for them?
They scratch their head. Maybe they're cleverer than I am, because they don't scratch their head as long as I did when I was writing my Christmas card app. Anyone else? Any comments? Any suggestions? Thank you.